Hello, my name is Shalene Trejo, and today I want to talk to you about security misconfigurations, which is number 5 on the OWASP Top 10. Let's go over objectives. Objectives: to educate stakeholders on the implications of security misconfigurations and how to mitigate them, understand risks and best practices. What is security misconfiguration? Security misconfiguration occurs when security settings are not defined, implemented, or maintained properly. The causes: default settings, incomplete setups, unpatched flaws. Security misconfiguration refers to the improper setup of security controls across our systems, including software, hardware, or networked environments. In the context of our company, which provides web-based services for a bank branch, this could involve issues like using default credentials for our databases, improperly configured firewalls, or failing to secure sensitive customer data. Such misconfigurations can lead to serious vulnerabilities, putting both our clients and their customers at risk. Why security misconfiguration matters for our company. We provide web services for a bank branch. Security misconfigurations can lead to unauthorized access, data breaches, and financial loss. Trust and reputation. A breach can damage customers' trust and the overall reputation of the bank. Security misconfigurations is among the most prevalent vulnerabilities highlighted by the OWASP Top 10. For a financial institution, the stakes are incredibly high. A misconfiguration can lead to unauthorized access to sensitive financial data, resulting in data breaches, final loss, and legal ramifications. Trust is vital in banking. Any incident can erode customers' confidence in our services and damage our reputation as a secure partner for the bank. Real-world example would be Capital One breach in 2019. Misconfigured firewall allowed access to sensitive data. 106 million records compromised. Significant financial and reputational damage. A misconfigured AWS firewall exposed sensitive data of over 100 million customers, leading to significant financial and reputational damage. This incident serves as a stark reminder that even established organizations can suffer from misconfigurations. For our web-based services for a bank, a similar oversight could result in the exposure of a client data, potentially leading to severe consequences for both the bank and its customers. How security misconfigurations affect web security. Expose sensitive data, increased attack surface, and not in compliance. Security misconfigurations can create several vulnerabilities that profoundly affect our web security. For instance, if our web application exposes API keys or database credentials due to misconfigured settings, attackers could gain unauthorized access to sensitive banking information. Given that we are providing critical services to a bank, any breach could disrupt operations, lead to financial losses, and compromise customer trust. The application might be vulnerable if the application is missing appropriate security hardening across any part of the application stack or improperly configured permissions on cloud services. Unnecessary features are enabled or installed, unnecessary ports, services, pages, accounts, or privileges. Default accounts and their passwords are still enabled and unchanged. Error handling reveals stack traces or other overly informative error messages to users. For upgraded systems, the latest security features are disabled or not configured securely. The security settings in application servers, application frameworks, Strut, Springs, ASP.NET, libraries, databases, etc. are not set to secure values. The server does not send security headers or directives, or they are not set to secure values. The software is out of date or vulnerable. Applications can become vulnerable due to various misconfigurations, including using default settings for database access, which can expose sensitive data, lacking input validations, making our applications susceptible to SQU injection attacks, overly permissive cross-origin resources, sharing CORS settings that could allow unauthorized access from insecure domains. Each of these vulnerabilities could threaten our web-based services and compromise the security of the bank's customer data. Best practices. Grant only necessary permissions. Make sure all systems are up to date. Regularly train staff how to keep the system safe. To mitigate the risk associated with security misconfigurations, we should adopt best practices tailored to our role as a provider for a bank. Regularly update and patch our systems to protect against known vulnerabilities. Implement strong word passwords policies and change default settings immediately. Use least privilege access controls to ensure that users only have the access they need. Conduct routine security audits and penetration testing to identify and address misconfigurations. By focusing on these practices, we can enhance our security posture and better protect our clients. How to prevent security misconfigurations, OWASP. A repeatable hardening process makes it fast and easy to deploy another environment that is appropriately locked down. Development, QA, and production environments should all be configured identically, with different credentials used in each environment. This process should be automated to minimize the effort required to set up a new secure environment. A minimum platform without unnecessary features, components, documentations, and samples. Remove or do not install unused features and frameworks. A task to review and update the configurations appropriate to all security notes, updates, and patches as part of the patch management process. Review cloud storage permissions. A segmented application architecture provides effective and secure separation between components or tenants with segmentation, containerization, or cloud security groups, ACLs. Sending security directives to clients, security headers. An automated process to verify the effectiveness of the configurations and settings in all environments. How to prevent security misconfigurations. Preventing security misconfiguration requires a proactive approach, especially in the context of providing web services for the bank. We can automate security configurations using tools that enforce consistent and secure setups. Utilize configuration management tools like Ansible or Chef to maintain secure infrastructure. Implement continuous monitoring and logging to detect the response to anomalies in real time. By integrating these strategies into our operations, we will foster a culture of security awareness that protects both our company and the bank we serve. Real specific actions. Developers, use secure coding practices and review configurations. Testers, conduct security testing and vulnerability tests. Non-technical managers, support a workforce of hyper-security awareness. To sum this all up, don't let security misconfiguration pose a significant risk to our company. If you understand this risk, adopt best practices, and focus on the security culture, we can minimize these risks.